हेलो फ्रेंड्स। आज हम पढ़ेंगे क्लास 6 चैप्टर 8 ए जर्नी थ्रू स्टेट ऑफ वाटर, यानी एक ऐसी जर्नी जो हम वाटर की स्टेज को जानेंगे, कितने टाइप्स के होते हैं और इसमें बहुत से हमें दिखेंगे क्वेश्चंस वगैरह। उसको इफ़ डिड इफ़ इट डज नॉट रेन वेल, इवन द माइटली ओशन विल बी ड्रेन्ड। यदि वर्षा अच्छी नहीं हो रही है तो इसका जो ज़्यादातर रीज़न जाता है वो ओशियन ड्रेन पे जाता है। तो ये भी एक आज का हमारा थॉट ऑफ द डे है। तो इफ़ इट डज नॉट रेन वेल, इवन द माइटली ओशन विल बी ड्रेन्ड। नाउ वी विल स्टार्ट इट। On a bright summer afternoon, Avi and Threev enjoy their Sikanji. After looking at the ice in the Lemnoid, Threev wondered about the nature of ice and water. Ice feels hard to touch and we can hold it our hand, whereas water can't be held in the same way, so they must be different substance. No, these are the same substance. We Avi has a counter view to Thrive. What do you think? Why? We can put water in the freeze of a refrigerator and check if it gets converted into ice. Yes, I know when water is left in the freezer, it gets converted into ice, but probably some time gets added to the ice in the freezer. Do you think 3 is right? Yeah, but this is the very difficult. How can you find out? So let's start it. Activity 8.1 and observe. Put an ice cube in a cup, leave it on the table and observe. Ice gets converted into water, and what can be conclude from the observation? Does this mean that ice and water are the same substance? Yes, ice and water are the two forms of the same substance. Their forms are also called state. These different states of water show many different in their behavior. Water flow, but ice does not. No. Water splaces, but ice does not. So now investigating water's disappearing act. It is a rainy morning. While going to school, Avi and Triv observe that there are a lot of water puddles in the playground. That evening, when they go to play, they are surprised to observe that some of the water in puddle had disappeared. Have you ever noticed water in the puddles disappearing? Where does it go? Discuss with your friends. Where else have you seen water disappear? Can you think of a possible reason why this happened? You might have observed that after washing the utensils, water left on the surface of the utensils dry up after some times. Does the reason you thought earlier to explain water disappearance apply in the case also? Avi wondered if water has speeded through that the surface of the utensil. Three thinks that water does not slip through that the surface of the utensil. Design an activity to investigate whose idea is correct. Both ideas probably correct, but this is the very difficult reason behind. Let's investigate. Take a tablespoon of water on steel plate as shown in figure 8.1. Observe whether water slips through to the other side of the people or not. देखो यहाँ एक चीज़ भी है, जब भी हम वेदर और का यूज़ करते हैं तो वेदर के साथ और आता है, लेकिन इफ़ के साथ इफ़ का कोई भी हम सेंटेंस देखेंगे ना तो उसके साथ और नहीं मिलेगा हमें, अगर वो बीच में कंजक्शन का काम कर रहा है। कीप ऑब्जर्विंग दिस एट regular interval until the water completely disappear. What do you infer? Is this activity enough to come to the conclusion that water does not slip through a steel plate? If water does not slip through the steel plate, then where has the water gone? This water gets converted into gaseous state called water vapor. The water vapor is another state of water. Let's think of another observation where you notice the water disappearing. While making dosa, we sprinkle some water on the hot pan and it's disappear. Where does it go? Let's draw. Draw a detailed sketch with labels and caption about what happens to the water. Water vapor is actually invisible, but the presence of teeny droplets of water in the steam makes it visible. The water which can the water which can I started here. The water which is uh, sprinkled on the hot pan gets converted into steam. Steam is actually water vapor, some part of which converted into water droplets. The process of conversion of water into its vapor state is called evaporation. The process of this is very important for you. Definition of evaporation. This is the important. So, definition: the process of conversion of water into its vapor state is called evaporation. The process of evaporation takes place continuously even at room temperature. Can you think of other example of evaporation? Drying of wet clothes, mopped floor, and sweat on our body are some example of it. Now, what do you think is the reason for the disappearance of water from the puddles? Is it due to slipping of water into the ground or evaporation of water? And third is both of these. So correct answer is evaporation of the water. Hand sanitizer disappear as you rub it on our hand. What happens to it? Because of their state is change, so change in evaporation. Another mystery: next day Avi Three and their friends decided to make lemonade. During the preparation, that take cold water in a glass slumber and add ice cube into it. After a few times they notice something exciting about the outer surface of the glass plumber. Let's find out concluding a similar activity ourselves. Activity 8.3, let's experiment. Take cold water in a glass tumbler, add a few ice cubes into it as shown in figure 8.2. Leave it undisturbed for 5 minutes and observe it. Record your observation and the question that rise in your mind in table 8.1 you noted, and you can also touch the outer surface of the glass tumbler to feel if there is any chance. You may have many observation and question here. So this is outer side of droplets of water. Our observation that arise in Avi's mind is there are some water droplets, teeny drops, appears on the outer surface of the glass lumber. Initially, water droplets are deposited and these droplets combine together to form bigger drops. It means देखो water droplets from bigger drops. You can also try the above process with a metal container. You may be curious about where the water droplets come from. Suggest possible reason explaining the appearance of water droplets on the outer surface of the glass tumbler. Discuss with your friends. Write down the possible reason in figure 8.3 and note down your notebook. So first, second, and discuss with your friend. Maybe ice has come out of the glass tumbler and melted. You may have various possible reasons. You may agree or disagree with the reason of others. Avi and Thrive agreed with a chain of reason. What do you think about the possible reason mentioned in figure 8.4? I think that some of the water may have seeped out of the glass tumbler. No, it can seep out. The level of water in the glass tumbler has not decreased. It might have decreased but may not be significant enough to be seen. With a tall and narrow bottle, even a slight changes in the level of the water of noticeable. We can take water at room temperature in other tumbler in and find out whether any water slips out. Continue the uh, discussion on the given reason or conduct activity to find evidence for the reason given to help in this discussion. Where else have you seen water droplets like this? You might have seen dewdrops on plants. Why do you see dewdrops more in the morning? When we boil the water in half-filled utensil and cover it with a steel plate, some water droplets accumulate on the linear side of the steel plate. Where do these water droplets come from and what do you think? When the water vapor present in the air comes in connected with a cold surface, it forms water droplets converted. The process of conversion of water vapor into its liquid state is called condensation. So, condensation definition write down here. Here started and end will be this. It means the process of conversion of the vapor into its लिक्विड स्टेट इज़ कॉल्ड कंडेंसेशन. और उसका रीज़न ये होगा कि जब भी कोई एयर में जब भी कोई ड्रॉपलेट्स होती है या पानी की छोटी छोटी बूंदें होती है और वो कोल्ड सरफेस एरिया में आती है, जैसे कि हमारे जो ग्लास में डली हुई बर्फ़ है उसके सराउंडिंग एरिया को टच करती है, तो वो ड्रॉपलेट्स जो हमें अभी दिखाई नहीं दे रही है वो चेंज हो जाती है वाटर के फॉर्म में. After understanding the concept of the condensation of water, let's go back to activity 8.3. Could the water appearing on the outer surface of the glass tumbler in activity 8.3 also be due to condensation of water vapor present in the air? Let's investigate it. Activity 8.4. Let's measure. Avi and Thrive conduct an activity to find evidence for their reason. You can also conduct the activity by following the steps given below. Record your data in table 8.2. Take a glass tumbler half filled with water containing a few ice cubes. Cover it with a small steel plate. Weight it on digital weighting balance. Observe the reading on the balance and record your weight after every 5 minutes. Continue observing for 30 minutes. Record your observation in table 8.2. Predict what will be happen to the mass of cold water kept on digital weighting balance Will it increase or decrease or remain the same? This is same because not effect of change of state. Measurement of mass in condensation experiment using a digital waning balance. It means 0 minute, 5, 10, 15, 20 and 30. Do you finding match with your prediction? Explain your observation. And now one more question and more to do. The amount of water vapor in the air is also known as humidity. It means amounts of water in our सराउंडिंग एरिया इन इट मीन्स एयर यानी हमारे जो सराउंडिंग एरिया में जो भी एयर होती है वो वाटर वेपर के अमाउंट में कितनी है उसे हम ह्यूमिडिटी कहते हैं. द डेली ह्यूमिडिटी डेटा फॉर योर एरिया इज रिपोर्टेड इन the newspaper and other sources. Compile the data for the year and study any partners if present. You may observe some water droplets on the glass tumbler comes to connect with the cold surface of the glass tumbler and gets converted into water droplets on the glass tumbler through condensation. There is an increase in the reading on the digital waning balance. Can we conclude that water is not seeping through the wall of the tumbler? Can we also conclude that the water collected outside the tumbler is only due to condensation? No, we can't say that conclusively from activity 8.4. What more can you do to show that water is not seeping from the glass tumbler? How could you modify activity 8.4 to find the answer? Repeat activity 8.4 with the following modification. Mark the water level on the glass tumbler with a permanent marker or a visible tab. What do you observe? What level in the glass tumbler does not go down but the extra water gets collected on the outer surface of the glass tumbler? What can you conclude from this? This activity shows the water is not seeping from the glass tumbler and the extra water is getting collected because of condensation. Because condensation, the process of the presence of air in droplets and contact with the cold surface area, and that will be changed in a small drop water droplets. What are the different state of water? Water is a substance that can't be observed in three different states in our daily life. That can be observed. Sorry. In the solid state, it exists as ice. On heating, the ice melt and gets converted in its liquid state. On further heating, water gets converted into the gaseous state. Let's perform activity 8.5 to identify the properties of different state of water. Activity 8.5, let's identify. But an ice cube in one container and transfer it to be another container of different shape. What change do you might in the shape of the ice cube? Record your observation in table 8.3. Pour water from one container to another container of a different shape. Observe how water behave compared to the ice cube and make a record. Did you notice how water falls from one container to other? What happens to its shape? Pour water on a clean surface and observe how it separates. When water gets converted into water vapor, how does it water vapor separate? Compare this with the spreading behavior of water. It means ice, water and gaseous state. Shape, ability to flow, ability to spread. What are the difference in the properties of water in solid, liquid, and gaseous state? Ice, this is called solid state, retains its shape, represent re- respectively of the container in which it plays, while water takes the shape of the container. Ice does not flow or spread. Water, liquid state, flow and changes its shape. Water does not have a fixed shape, it takes up the shape of the container in which it's kept, in which it is kept, but the volume of the water remains constant. Does water also possess the property of spread? Yes. Water also has the property to separate while keeping the volume constant. Water vapor gaseous state exhib- exhibits a property of spreading out in the entire available space. Gases do not possess a fixed shape. Water vapor exists even at room temperature, though it invisible to us. It is present in the air around us. The water that evaporate during process like drying of clothes or mopping of floors contribute to the water vapor in the air around us. You are now familiar with the three state of water. Some other substance also exhibit these state. For example, wax, oil, and ghee. Let's look at some more example of solids, liquid, and gas. Look around and find some examples of solid substance. Some example could be stones, wood, and glass. What are the other examples of liquid you can think of? Here are two examples, milk and oil. Think of five more examples. Have you ever noticed that you can smell the food being cooked even without entering the kitchen? How does this smell reach us? It is because the smell of yummy food from cooking spreads through the air and reaches our nostril even if we are not in the kitchen. What are the other examples of gases you can think of? And what about oxygen and carbon dioxide? So, how can we change the state of water? So far, we have learned that water can exist in solid, liquid, and gaseous state. How can you change the state of water? More to know, atmospheric water generator AWG machine collect water from humid air to produce drinkable water. This is done through condensation of water vapor by cooling the air. This process is similar to formation of the drops of water outside the glasses tumbler filled with ice cold water. Atmospheric water generator. Now, how can you quickly change ice to its liquid state to water? If we have to change ice into water and water into vapor, we have to supply heat to it. If we want to change water into ice, what should be done? It can be done by placing water in a cold environment such as a water freezer, and it is converted into ice. If we take the ice out of the freezer, it melts and is converted into water. Can you think of any other example besides water that can change from solid to liquid? Yeah, a candle which is made of wax is one such example. We change the liquid wax back into solid state we should cool the liquid wax to change into a solid. What are the other liquid you have seen which get converted into a solid? Have you ever seen coconut oil getting converted into its solid state during the winter season? Hence, we can see that water and other substances change their state on heating or cooling. The process of conversion of solid into liquid it is called melting. The process of conversion of liquid into solid state is called freezing. And first, melting. Let's check the connection between different state of water through activity 8.6. Let's complete the diagram. Fill up the blanks box in figure 8.5 marked A, B, C and 1, 2, 3, 4 for conversion of different state of water using the words given in the box. Two words have been filled for you. Melts water. Melts and freezing point. Solid, liquid and gas. So first solid to liquid changing state is called condensation and liquid to gas evaporate and third is gas to liquid this called freezers. एक दो तीन चार पाँच melts and this called gas. Okay, first column use in evaporate and this liquid and this gas and this freezing point and this condensation. Who can water be evaporate faster or slower? In session 8.1 we have learned about evaporation. Let's explore it more. Observe your surrounding. What are the conditions that affect how fast water evaporates? What difference do you see in evaporation on a cold day versus a hot day? Does with your friends. Discuss with your friends. The following word may help in your discussion. Fun, fan, drying clothes, sweating, windy days, hot days, rainy day. Let's perform activity 8.7 to investigate condition that will affect how fast water will evaporate. Activity 8.7 let's investigate. Take water in a small cap of a bottle. You may use station sanitizer in place of water. Take the some amount of water in a plate. The exposed area of water in the bottle cup and the plate are different. Keep both of near each other. Record the time taken for the water to completely evaporate in each case in table 8.4. What condition did we keep the same? What did we change in this investigation? What did we measure? These three types of questions. And now reflect on what you did really well in this activity. Table 8.4 Finding of the investigation. Exposed area of water, time taken for complete evaporation, less bottle cap, more plate. What can you conclude from this investigation? If you spread out water on a plate, it's Area exposed to air is larger, therefore evaporation is faster. What would happen if milk is taken instead of water in the above activity? Other condition, because of milk bonds are very strong with other substances like proteins and vitamins, and water only hydrogen bonds so easily break down. Other condition which affect how fast water evaporation, design an activity similar to activity 8.7 to find out what are the other conditions which can affect how fast water will be evaporate. What would you change? What would you keep the same? Perform this activity. Use table 8.5 to record the data and discuss your observation. So you can record. Other than the condition you have explored to find how water can be made to evaporate faster or slower. You can also conduct activity 8.8 to explore its further. Take identical caps of two bottles, pour equal amount of water in each of the cap. Place on the cap in sunlight and keep the other set of us activity 8.6. Observe the two cups of bottles after every 15 minutes. Record the time taken for the water to completely evaporate in each case. You can also repeat this activity on a windy or rainy day and record your observation. So you can observe all things and note down your um, record, different evaporation, lower or faster. What conclusion can you draw from activity 8.8 and other similar experiments? Water evaporate faster from the cap kept in sunlight compared to the cap in inside. It is a common observation that the clothes dry faster on a hot sunny day. Do clothes dry faster or slower on a windy day? It is once again a common observation that the clothes dry faster on a windy day. With the increase in the amount of air, water evaporate faster, and the amount of water vapor in the air is more on rainy days, and hence rainy days are more humid, right? It is also common observation that clothes dry slowly on a rainy day. On a rainy day, water evaporates slowly. If the amount of water in the air is already high, more humidity, water evaporates slowly. If you want to dry your clothes on a rainy day, how can you make it faster? Mm, Help of fan, cooler. Cooling effect. Avi's mother purchased a new matka earthen pot to replace the stainless steel pot for storing drinking water. Upon retiring from school, Avi noticed the earthen pot and drank water from it. Avi expressed surprise and asked, "Why is the water in the earthen pot so cold? I never observed water getting cold in a stainless steel pot. What do you think is this reason?" Water seeps through the surface of the earthen pot and evaporates, which imparts a cooling effect on the water. What are the other examples of cooling effect? Sprinkling water on the floor or the roof during summer to cool it, another example. How do you feel when you rub sanitizer on your hand? So very feel touch like very cold. Let's perform activity 8.9 to observe the cooling effect by making a sample an electricity free model of pot in pot cooler. Activity 8.9, let's make a model. Take two earthen pots of different size. Fill the bottom of the larger pot with a layer of sand. Place the smaller pot into the center of the larger one as shown in figure 8.7. Fill the gap between the spots with more sand. Pour water in the sand area. Place lead or wet jute sack to cover the top of the smaller pot. You can also make a drawing of the pot in pot cooler once it is ready. It means small pot and a larger pot, wet jute sack, layer of sand and lid. Allow 4 to 5 hours for the mini pot in pot cooler to cool down. The time range can be influenced by many conditions. Observe and discuss how it creates a cooling effect inside the pots. Keep some vegetables and fruits in its. Observe for a week on daily basis to check for the freshness of the vegetables and fruits kept inside the cooler. You will have to add water regularly to keep the sand moist. For how many days can the vegetables and fruits be kept fresh in it? What are the conditions which can affect the number of these days? What else can be used in place of sand for better cooling? You all may be familiar with this unique clay pot which is called surahi. In summer, surahi is used to keep the water cold, right? How do clouds give us rain? Why does air containing water vapor go up in the atmosphere thin layer of air that surrounded the earth? As we know, gas balloons containing lighter gas go up in the air. Similarly, water vapor is lighter than air, causing it to rise. No. Condensation plays a significant role in the process of bringing evaporation water back to Earth's surface. How does this happen? When air moves higher above the Earth's surface, it becomes cooler and cooler. At certain height, the air gets so cool that the water vapor in it turns into droplets which are generally formed around dust particles. These small droplets float in the air and from clouds. Many droplets join together to form bigger droplets of water. Some drops get too heavy that they start falling. These falling water drops are what we can rain. Under special condition, it might also fall as hail or snow. Hail or snow, right? Because we also read out water condition, humidity, evaporation, right? And hail and snow. Avi enjoyed the rain and create a poem. You can complete the poem and present in your class. I wonder, oh, I wonder so. Which path does water choose to go? I wonder, oh, I wonder so. When does it snow? Wonder, oh, I caught a wonder cold. How does rain fall? And this last line for our poem, I wonder, ponder, and dream each day as water journey takes its way. Activity 8.10, demonstrate the role of dust particle in the formation of clouds. Caution: handle burning paper carefully. Activity 8.10. Let's engage in a group activity. Take an empty, discarded 1/3 plastic bottle, 1 liter plastic bottle, pour about 1 cup of water into it. Close the lid tightly. Now quickly seize and release the bottle continuously for about 2-3 minutes. Observe the space above the water in the bottle. Repeat the same activity after adding a small burnt pieces of newspaper into the water. What will you observe? In this case, you will observe some haziness clouds about the water in the bottle, right? The burnt newspaper provides very small invisible dust particles around which water vapors condense and form clouds. Let's perform activity 8.11 to present our understanding of how water changes its state and its movement. Activity 1:1. Let's understand the process. Label figure 8.9 using arrow shown and the words given in the box to show whether is stored, how water change its state and where it moves. This is the evaporation and this is the okay. Note now. Firstly, cloud, lake. This is lake, groundwater, evaporation, condensation, rain, and snow. Precipitation. The water from the ocean and earth's surface evaporation into the earth atmosphere as vapor and returns as rain. Rain means no rain, precipitation, and precipitation types of rain, hail, or snow. Ultimately, following back to the ocean, this circulation of the water is known as water cycle. Only a small portion of water available on the earth is fit for use by plants, animals, and humans. Most of the water is in the ocean and it can't be used directly. We use water for drinking and also for many other activities. The numbers of people using water is increasing with a rise in population. The increasing demand for water causes it shortage in the many parts of the world. Hence, it is very important to use water wisely and avoid wasting it. Let's keep our water bodies free from pollution. You will learn more about water and its conservation in the chapter Nature's Treasure. So next chapter and our keywords in this chapter: condensation, evaporation, freezing gas, humidity, liquid, melting solid, water cycle, water vapor, experiment, investigate, observe, predict, caution, reason, record. And any mistake in chapter using any parameter, so that's you will improve and below our comment. Thank you.